Hello everyone, happy Independence Day. This is Happy Indian Independence Day. And then, yes, so we are back with one more testing lab exercise. And the mission or the exercise statement was most of us might have used a food delivery app. Also, the assignment of the delivery boys or delivery person is not random. I want you to think on these lines. Research on the possible algorithms and submit your test ideas to test the algorithm. The focus will be on your analysis, research of algorithms, and test ideas to test the algorithms. So, here we are. Welcome everyone. You can introduce yourself and we can get started.
Okay, so hi everyone, this is Rahul, and I have paired up with Apoorva to come up with an analysis of this algorithm and some possible test ideas. So, yeah, looking forward.
Hi everyone, this is Apoorva, and I and Rahul have collaborated on this exercise, and we have prepared the analysis together.
Okay. Yes.
Hello, Gaurav this side. So I would be acting as an audience and listen to the great ideas from Apoorva, Rahul, and others.
Same here. This is Chandra, and I have been an attendee, 2 times attendee of the test lab, and I'm also attending this session as an audience. So looking forward to it.
Okay, perfect. So, let's get started.
Okay, so I'll start with my screen sharing, and 1 second, just I would need a feedback from you. Then you can see my screen. Just let us know.
Yes.
Okay, so we have created this map where we talk about the algorithm. So we have created 2 maps. In the first map, we will talk about algorithm. In the second map, we'll talk about test ideas to test the algorithm and what all we can do with the algorithm. So, this is the team. Apoorva and I have paired up on this online food delivery assignment problem. So I'll start with the variables that are actually involved into this uh, problem. So there are different kind of variables that are actually involved when you want to develop an algorithm which can be used to do effective assignment of delivery executives. So first variable and very important variables which all these food delivery apps use is the delivery system. There is a database for it where they store the historical data of customer orders, like how many orders the customer have done in the past and the trends associated with that. The restaurant orders, that how quickly, fast, and order and what scale at which the restaurant delivers the order. And third is the previous delivery times, that like what all in what all time the restaurant was able to deliver the order, and then how much time the customer takes the order, and what is the last mile time and all those things. So that is the first variable. Second is the real-time signals which affect this entire thing, that is associated with the traffic, the weather conditions, and other factors. For example, sudden log out of the user, or sudden increase in the demand which happens after 8 p.m. or 8:30. So those also affect this delivery cycle. Then the customer location is also a factor which determines how this assignment has to be done. Then serviceable restaurant which are available at that moment of time. The available delivery agents which is also one variable. Then the current demand for orders and the customer conversion ratio. So not all customers who log into the food delivery app actually end up with an order. So not every user who is right now looking for some food will need a delivery executive to uh, basically serve him. So this conversion ratio of the app or the time, that is also very important in mapping. So that's part one of that, which was the variables. Next is delivery equation factors. Yes, Apoorva.
Yeah. So here we have considered the application as Swiggy, and we have analyzed their delivery equation that they use for the delivery services. So the factors that affect the delivery equation are as explained here. First is the assignment delay, which is the time that is taken to assign a delivery executive for a particular order. Like as in when we place an order, the time that is taken for a delivery executive to be assigned to that restaurant or for that order, to that mapping time. And the first mile is the time for delivery executive to arrive at the restaurant. Preparation time is the food preparation time, and last mile is the time taken for the delivery executive to deliver the food from the restaurant to the end user. So the equation goes by delivery time is equals to maximum of assignment delay plus first mile time or prep time plus the last mile time. This is the equation on which they work on, and as they have mentioned that this gives them the average time. It need not be an absolute value, but yeah, most of the time it is an average value,
Yeah.
which they
So,
work.
yep. And so this is actually the delivery equation across which this entire delivery cycle works. Now we wanted to talk about some risks that from the business point of view, that what risks are there which even drive this algorithm. So first thing is that no matter how correct the algorithm is and how much correct mapping of the delivery it does, but they have to execute it under 0.5 seconds. So within a fraction of a second or within a second, if they cannot map it, then possibly there is a risk. I'm getting an echo. Yeah. So possibly there is a risk to lose the customer. So they have to do really fast and optimized computation. That second is that if for example within that time if they display too low serviceable restaurant because they could not compute for some reason, then that's a risk because customer will not find the restaurant that they are looking for and they will leave the app. Or if they compute it and give some reasonably high time, then also the customers will leave it, that the delivery might take 1 hour or something, so then in that case also they will leave it. Or too low delivery time, if they offer for example they say 10 minutes and then in reality it doesn't work out, so then in long run it will create a bad customer experience and they end up breaking all this promised time. So delivery agent and another risk is that delivery agent can also keep on rejecting the order, so that's a problem which is in this case. And last is the historical data that we have. So one can say that okay, we already know that like some 10% of the delivery orders are going to be rejected or 15% are going to be rejected. So why can't we plan for that? But historical data actually only gives us average value for making a decision. So they are not absolute. They just are good enough value to know and prevent to some extent, but are not as like very absolute. So that's one risk. And next is that essentially like we have to target whenever there is an algorithm, it has to give a Goldilocks value, which would be just right. So if the value is too low, then you have a fear of creating a bad customer experience. If the time is too high for this assignment, then like very few people would be ordering it, they would leave it. And there is this very fine line where you have to deliver it, so like where you have to promise and deliver, so that this entire algorithm as well as the business works. So that's this concept of risk and why like we need to look at how this is calculated and also what is this assignment algorithm and how the time is computed. So yeah, Apoorva.
Yeah. So to compute the availability of delivery executives, there is a procedure that they follow. That is, they track all the delivery executives and then read their status, whether they are available or they are in progress of delivering an order. So in after that, if the status is available, then they calculate the how much pending time is available for that delivery executive to be available.
And if it is not available, then they calculate that how much time the delivery executive will take to get free from the existing order which he is servicing right now. So these are two computations which work in the background whenever you open an app and like what the delivery team starts working. So yeah, let's talk about these strategies or basically the 3 algorithms that they do.
So, based on the availability of the delivery executive, Swiggy uses 3 different strategies to map them. So, the first one is just-in-time assignment. So, here what happens is the delivery executive is initially ideal. He is not in any in-progress ordering or delivery. So, he is right now available.
Sorry, can you change ID EAL to IDLE first?
Yeah.
Continue.
Yeah. So then the restaurant starts preparing food and the delivery executive search begins. So then parallelly the restaurant will be starting to prepare the food, and then parallelly they will assign the delivery executive as well. But here we have 2 risks. That is, delivery executive might end up waiting if the food preparation takes too long. So here there is a chance of wastage of time at the delivery executive end. And another risk is delay is equal to estimated prep time minus average first mile. So if we consider the if we give the estimated time, sorry, um, yeah. So
Yeah.
what we are trying to say here is that the delay that can be caused due to that average first mile time, that is the delivery executive reaching the location of that restaurant, and the estimated prep time. So there will be a delay that can be caused there, and that could be a potential risk.
Yep. And essentially this estimated prep time as well as this average first mile both come from a historical database. So these are all average values and these are not absolute values. So they will eventually error out and you have a risk of a delay, and that delay could be more also in some cases. For example, if the prep time is too high or the average first mile is too low, so then the delivery executive just reaches within a minute, and the time taken to create that order is suppose 20 minutes, so you end up wasting 19 minutes. So that's a risk in just-in-time assignment. So a better thing that they try to do is next order assignment. So here what happens is that delivery executive is already working on an order N. So delivery executive is right now working on one order which is assigned to them, and next assignment is given based on the completion of the first order and nearby order that they can pick. So essentially, if they are going to some location A and if they get another order, so from their database they check that at this location is there a nearby restaurant from where they can pick and a nearby customer where they can deliver. So they assign it based on that time, so that in that first mile time plus the time taken to complete the existing delivery can be matched to the estimated prep time, because the prep times are generally very higher compared to the first mile times. So that helps and it increases the pool of eligible executives, because now you also can search for delivery executives which are going for a delivery or which are already doing a delivery and which are idle. So you have both those pools, and that's the next order assignment. And the third strategy is batching. So batching is actually clubbing of 2 orders at the same time from 2 customers who are located nearby. So now this is a very typical and hard problem for the Swiggy or any algorithm to solve, because the complexity is NP hard, and which makes it how much you try, that might not be the optimum solution. And as we know, there is always a risk that if you don't compute that within a second, then you end up losing a customer. So the benefit with batching is that it enables more delivery with a limited set of executives, because each executive can then take 2 or more such orders. And the problem why it's so complex is that for 2 or more orders to be batchable, we need to calculate the new delivery time of all the orders in the batch and make sure they still adhere to the promise made to the customer. Because initially, every customer is promised with some delivery time when they open the app, and when you batch them, then you have to make sure that now the new delivery time is also the same as the old one which you promised. So that makes it very hard, and that has to be done very quickly. Next is factors that affect this batching is that concurrent orders, proximity of customers, proximity of restaurants, time and order rate, and traffic and other factors. So these are a lot of factors which drive this batching and things associated with that. And it's very much similar to the vehicle routing problem, like where you have one vehicle and like different people want to go to different places, but they are in a similar path and how you have to route it. So this batching is very similar to this, and this concept is used heavily in this delivery plan. So these were all the algorithms which we wanted to talk about, like which they use. So that's about the algorithm. If we have any questions here, we can take right now.
Hi Rahul, this is Nishant here. I have one question.
Yes, Nisha.
How we can test the batching?
Mm-hmm. So, Nishant will talk about test ideas in the like upcoming part. That how to test it, but essentially you have to look at the historical data. You have to look at a lot of factors, vary them, and then you can do it. But still, like there is no optimum or expected result which you can expect from batching, because it's an NP-hard problem. So there is no single like binary answer for it.
Okay. And I guess there is one more area which we can add, which is a map, Google Map.
Yeah, so why Google Map cannot work here? So we'll even talk it later, but just to answer it, at the scale at which all these Swiggy and delivery apps work, they have mentioned that Google app is first too time consuming for them, and second is that it doesn't actually give them the last mile correct times. And most of the delivery executives which work for these delivery apps, they work on two-wheelers. So the time that Google Maps give for two-wheelers is not accurate first. Second is that Google Map will never give a time. For example, if they reach at the start of the building to the point that they have to go to the for example, say on the 8th floor and deliver it. So all that data Google Map will never give, and that will actually come from their historical database. So that's why they don't use the Google database or any other available maps, and they have built their own system. This is for like.
Then how they will get to know current traffic situation?
The current traffic situation, they might be getting it from there, but not for the distance calculation or time calculation.
But they also have their own system where they analyze the traffic and weather conditions as well.
Okay.
So, do they consider that a person, like maybe he has not got the order? For example, in optimizing, you might be giving one person the whole task and there are 99 sitting ideal. So, don't they consider that suppose this person has got 10 orders for this day, now we can give to the people who have not got, or like minimum trips like in Uber and all that, at least minimum 6 trip promise, that factor.
The only thing that drives is the location proximity and availability. So, for example, if somebody is totally away from any restaurant, like they can service anything in like after 1 hour, then most possibly they will not get it until and unless all the existing delivery executives are occupied.
But this factor I think would be used when there are say 3 people in the same area and they are almost in the same time. So don't you think that, and one of them has not got the work since morning, so they can consider that at least we should give that person some work because he may be ideal for maybe 2-3 days because of such algorithms, if that factor is not considered at all.
If they are in the same, I think they would essentially get the next order. So the classic problem is that in a normal situation they are all like they need more executives, and they are always like on a risk of like running out of executives. So the case you are saying is valid maybe, but I think that would happen if the number of orders are pretty less in that area.
Yeah, maybe like as you said that at 8:30 it increases. So if like 4 or 5 p.m. snacks time where people are ordering less, maybe So in that case, that could be one of the factor to assign, like the person who has not got any order and he is in the same proximity, because at some point of time, if people are equal, at some like till something, your algorithm can work, but after that it would be random after a certain point of time.
Yeah, I think maybe. I mean that could be, but when like we were reading about the blogs, we couldn't find anything for that. But yeah, maybe that is an possible something that we do.
And how they are merging orders. For example, same person is ordering from the same restaurant with two different orders. So two delivery executive will come to order deliver, or they will merge the order.
So that they will do based on the location of the restaurant and the delivery executive. And if the batching is possible, then only they will batch it. So batching is actually a very typical concept where basically you have to club two orders from two restaurants for let's say two different customers or one customer, but the delivery time should be same.
But Rahul, that can be calculated, right? Earlier, like it can be hard, but it's like you have to achieve a time which is equal or less. So if you make the calculation and it's coming equal or less, it can be done.
Yes, then it is.
Correct. Okay.
But from the different restaurants, like right now, in the apps which I explored, they are not merging, right? So they are recommending us to place two separate orders. It's like two different couriers actually. So the one which I tried here, like the Uber Eats and Postmates, so that is like kind of a cloud model, and they are saying like pick up each, if it is a different restaurant, like different service, they are picking up a different, it's a assigned to individual courier.
So are you talking about food delivery app, Deliverable?
Yeah.
So essentially, see, the time between both the order also matters. So is it like you have immediately done it one after the other?
Yeah. So the Uber Eats, what I tried is one I choose from like a coffee, different restaurant. So another one like another food restaurant. So I was hoping like both will be clubbed into the cart, same order itself. But so I was asked me to choose a new order altogether.
Okay.
So like
what they are doing is they want to deliver in optimum time. So for that to happen, they might have put it into different separate orders.
And just to add to that, I think recently I ordered from one of the online apps. So you are taking a case where the restaurant itself is different, right? So even if you order from the same restaurant, they might not allow you to add, because there is a complexity involved if you cancel that order, right? It has to generate a refund at two places. So the order ID and all. But in your case, if it's totally a different restaurant, then if it is delivered late to you, then you will be more disturbed compared to than if a single person would have delivered. So maybe sometimes I have seen this, like even if you order from the same restaurant, two different people will come to deliver to you.
Yep. So essentially, David Prasad, to sum it up, like the main thing that drives this algorithm is this Goldilocks value, that not exceeding it what they have promised, and not not understating and then like delivering it too late. So that is about the algorithm, and how does it?
And Rahul,
I have a question, Rahul. Sorry.
Yes.
So since Goldilocks value only talks about customer ordering first, or if I'm a customer who just order a sweet and then I forgot to order some samosas. So there is no order iteration, ideally, at least on Swiggy, that I'm sure of. So I need to place a second order. So this valuation is applicable in the second order, subsequent second order as well.
Just in each order.
Yes.
Okay.
And Rahul, one last question. So don't they consider that about how much time that person takes? For example, like see, different people works differently. So there may be an old uncle who is a delivery guy, and a person who is maybe he delivers very fast, and also don't they consider at person level?
Yes, that is what, like from the historical data, this previous delivery times is like considered.
So this is related to a person, or is it related to like what previous delivery time?
This is related to both. This is related to the delivery executive also. This is also related with the restaurant. That how much time, for example, McDonald's takes to service a burger at 8 p.m. versus say some other uh, restaurant takes. So this is all that log.
And also in that customer orders historical data, they also consider the previous order history of the customer, whether he was ordering bulk items or single items, and with what frequency he was ordering, like at what times, morning, evening. So all that is considered in the historical data.
Yeah. And how much time they actually convert. So maybe like they just open it, see for 2-3 restaurant and just close it. So then they have to also consider this, because they cannot keep the executives logged for these. Like, for example, say there are 20 people who are opening this app at this point of time. So they cannot block 20 executives for them. They know they have, for example, they have 5 delivery executives, and they know that the conversion ratio is something that we can accommodate. After that, if it increases, then they start showing we are not servicing or we are experiencing delayed times and all.
So is it like pooling that resource for like based on the historical data and assigning them?
Yes. So that matters a lot here.
And in the starting, you said that they have to take out the restaurant in 0.5 seconds. So is it not like in this case, we don't see that any restaurant just get closed up, right? They have fixed time generally, like it opens at 11 and service till that kind of stuff.
So essentially, for any customer, so this serviceable restaurant is not the list of serviceable restaurants which are in the city. Restaurant, they can offer to the customer at this point of time.
So it is basically if a customer is searching, opening the app, then the list of the restaurants that would be serviceable to him, that should be shown up to him within less than half a second. So if it's taking more than that, then there is a chance there is a risk that the customer may go to some other app to order.
Yeah. And one thing that I think Gaurav is wondering about is that if, like, for example, in a city, number of serviceable restaurants are constant, the time is constant, then why even it takes that? Why can't we display that list? The reason is because we have to display list based on the availability of the delivery executives from a food delivery app. For example, 5 kilometers away from your home, there is one restaurant which is serviceable, but there is no executive that is free right now for next 10 minutes. So then they will not show that right now. Or maybe they will show it, but not dispatching or something like that. So that computation, everything they have to do within 0.5 seconds. Because if a customer selects a restaurant and makes an order, then they have to deliver it.
Got your point. Basically, service is available from the restaurant, but by the app or not, that is taken care.
Yes. So I think we have covered all the questions. So let's go to test ideas. So
I have one more question, Rahul. So there are most probably, as per my understanding, there are 3 different apps. One restaurants are using, one delivery guy has, and one customer has. So how they are going to sync the data between these 3 apps?
Okay, so Nishant, actually we have only studied from the algorithm point of view. I think what you are asking is from the application point of view and how they are syncing the data. So we have actually not done that.
Okay.
Yeah. So I'll now go to the test ideas. So assignment problem test ideas. So we have categorized the ideas in. I'll zoom up more. So for 4 categories, like how we are going to compute these ideas. So first is the product.
I think either collapse all and then expand node by node.
Yeah.
You know the shortcut. /
Press that /, it will do all.
is that for this Xmind? Because I think the shortcuts for Xmind 8 and 21 are not compatible.
And you can zoom into 150.
Okay, so the assignment problem. So we have actually factored out some areas on which we have thought of some test ideas. So the areas are product, project, business, team, external, and stakeholders. So we'll first talk about product. So in product, we'll talk about just a second. Okay, so we'll talk about capabilities first. And yeah, Apoorva, you want to start?
You'll have to zoom in a bit,
Yes.
Yeah.
at least 120.
Okay.
Yeah.
Now,
Yes, better.
Yeah. So going by the capabilities, we have explicit requirements and implicit requirements. The implicit requirement indicates that the result should be highly accurate, that is optimized value, and explicit is that result computation time should be less than 0.5 seconds. That is what it is. And examples for capabilities test using the data from different sets of timing, that is morning, evening, night, all those things, and locations will be remote, metro, suburban. Based on that, it will change. Weather conditions, whether it's rainy, summer, winter, so based on that, it will change. And then pairwise testing can be done for all these combinations. And the other specifications include preference to high performing delivery executives, that is rating based, and tests on high demand areas versus low demand areas. So that is another capability that we should consider for testing. Yeah. Next, you can pick up volume modes now.
One question, Apoorva. So, the test on high demand areas basically was saying more frequent orders on the peak
Yes.
hours.
There are some areas where frequent ordering will happen, and when compared to, like, if you compare for the metros and suburban areas, there'll be a difference, right? They will be ordering frequently, the frequency of orders that come in. So based on that, high demand areas and low demand areas.
yeah. Next is the failure modes. So there can be internal and external failures, like a delay from restaurant. So there could be some abrupt delay from restaurant which is not planned for, or similarly for a delivery executive also there could be a delay. For example, there is some like maybe the bike got break or something like that. Then maybe another external kind of thing which is not in the hand is that, for example, multiple cancellations start happening by delivery executives. So they have promised one time, but the first delivery executive cancels, second, third, and maybe more. So that's a point of failure, that how to handle that. Then some anticipated or unexpected issues, that is like weather, or the weather changes, or maybe there is too much rain that comes up, or traffic increases, or there is some jam, and maybe some accidents happen or something. So these are some unexpected or anticipated issues. Then some realistic and provoked issues could be user keeps cancelling order after booking it. So maybe there is some malicious user who tries to do that. So that's something, or maybe delay due to batching. So you try to batch, but in actuality there could be a delay. So that's another failure mode. And challenge the fault tolerance. So for example, there is a lot of dependence on this historical database for computation of a lot of things. So if that goes down, then that's also a failure, and how like they will recover at that time. So that's the failure modes. And next is models. Yeah.
So, one question on the historical thing, right? So, for example, if any business or any app, if it comes like very first time, so they may not have any historical thing, right? Just like kind of a gut, based on the industry data, they might come up with some algorithm.
They would still have two historical data. For example, for user, in that case, they won't have any historical data, but they have historical data from the restaurant and from the delivery executives.
Okay, so that's it. Okay,
And
the delivery
just to add, Devi, sorry, since I have been a fan follower of Swiggy and Zomato, since I'm a single. So the way in an area Swiggy evolves is they add 2 or 3 restaurants in starting and then subsequently or gradually it improves. It is not like that when Swiggy was launched in Varanasi, it was not launched for all restaurants. It is like within 2 weeks and then 4 weeks and subsequently.
Okay. Yeah.
And do we want that it should still work if a DB goes down? Because if there is some logic built in it, so it can't work, right? If I take the database of an application, if we want, it can work, but is it the algorithm designed in such a way that if it goes down, it can still work?
So that is what we have to test. I mean, that is the idea. I mean, making it down and then seeing what happens. I mean, because if it goes down, for example, say 30 minutes, we lose a lot of business. So how to do that? Yeah.
So it should have disaster recovery. Basically, we are trying to test, right?
So yeah, fault tolerance basically. Yeah. So that's one part. Okay. So next model, Apoorva, you can take up.
Yeah. So the models that we have considered here is SFD pod from HDSN. So for structure, we are considering the code where we have the algorithm, and the functions we are considering the calculation of time and the testability. And data is the different sequences or combinations that we can test, and the input and output values that we can test. The interface, we are considering the network here and the GPS locations that we can test on. And platforms is the embedded components that are involved here. And operations, we are using the common use and disfavored use operations. And timing is the rate and concurrency with which the orders are taking place.
Yeah. So that's about some model which we thought of. Next is the data. So in data, if you see, like, we will try to like this CRUD, we will try a CRUD. So it would be like create a new order, read the status of the order and of the delivery executive, update based on the batching info, delays or real time factor, and delete. So for example, there is an order cancellation, so order gets deleted. So this is CRUD that we have to test. Then easy or tricky data. So for example, sudden shutdown of a restaurant, so which is not planned, but that actually happens. Now how to handle that? Or sudden rejects by delivery executives, or by multiple delivery executives. So that's something that we have to test, that what will happen if this starts happening. Then there are some dependencies of data also, like the GPS information, like maybe for traffic and all, and something that we take from some other app, or we built our own system, something like that. Existing orders database, historical data, and real-time factors related data points. So all this would come as a dependency. So that's about data. So yeah, we can talk about surroundings.
Yeah. So the surroundings is the applications that are involved here. That is the DB layer, the GPS information that we are getting. So the device, how precise that device is giving us the information. So based on that.
Yeah. And then we can do some white box analysis on the design and the code. So first is that look for common design issues that are generally like occurring on this like these kind of algorithms. Maybe analyze the design pattern that they have used to build that, and in the code when they will build, we can check the coding guidelines or standards and loopholes if any. So that's something that we can do. But essentially, maybe we are not sure that this part would even come, because this part actually comes when like you use an algorithm to develop something. So we just thought that if somebody wants to do it, maybe at a first case level we can think of it. But yeah, that's something. So next is product history.
Yeah. So in product history, we are covering the error catalog, that is the existing issues that are reported by the customers, the already known bugs that are present, the DB crashes that could occur, and other error logs that could happen. And older versions can be used as oracles for if we are thinking of a new algorithm that we can consider. So we can consider the older version as an oracle and then test it based on that.
Yeah. Next is rumors. So rumors can also help us to like in some test ideas. So we will look for issues reported on, for example, say app stores, video blogs, informal sources and social media. So there are a lot of things that get reported. Customers like talk about them. So maybe they don't report it, but directly put it on social media. So that's also one thing that can be looked into and could be used as a test idea to investigate more. Yeah. Next is competitors. Yeah.
Yeah, so the competitors would be companies that were working in the similar domain. So that would be, for now, we have considered Zomato, Foodpanda, and Uber Eats. And what we could do as for our testing, we could research on their algorithm and test it as well, how it works for us.
Yeah. So next is the project. So yeah, there are some things that will actually help in the project. So first is the test artifacts. So essentially some alpha beta testing reports, like because whoever is developing will expect some reports and look into that for ideas of to design our testing. Second is if there is a testing team and they have already tested it previously, so those reports are also helpful. And for example, some upstream layer, they are using our algorithm to build an application. So any kind of testing reports and logs or issues that they have found, so those are some good test artifacts that we would like to look to design our test ideas. So that is first. Yeah.
Okay, so in conversations, there will be informal and mention in passing conversations that we could consider in the project as for test ideas.
Yeah. And then we talk about deliverables. So there are many deliverables that will also be included, like with this algorithm that we would like to like test. Well, first is the release notes, like what they are building and what changes they are doing to the existing algorithm. Second is the README, which talks about each thing that they have considered, factors and all, which we were actually talking about in the algorithm part. So any information related to that, maybe some training material that how to use this algorithm and how to consume it, and what are the changes that this algorithm, how it responds to change in the data, and also any kind of such a data or demo or any kind of a pseudo code that they have written to explain this like algorithm, or any kind of a help or documentation or anything that is available. So that is what we will look for. And last thing is tools that look for right tools to help with the testing. So essentially for now, we don't know any tools that can help us with algorithm testing. When we were searching, we found some IEEE papers on algorithm based testing. So that could lead us to some tools or some creation of some tools. Maybe we want to create some tools to do that, test out for some complexities and all. So that's something to watch out for. So that we have considered that we will need some tools for that, sure. And yeah, so business, you can take that up.
Yeah.
Oh, sorry. Yeah.
Yeah, so coming to business, the first and foremost purpose of this is to have service timely delivery of food to maximum customers through existing delivery partner network with maximum restaurant coverage within the optimum time. So this is the purpose that for which we have that equation, that is to serve maximum people in the stipulated time with utilizing optimum number of delivery executives.
Yep. Next is the business objective. So first business objective or the big picture is that, or that we think could be, is that maybe develop number one food delivery algorithm. Every company wants to optimize their algorithm, and the biggest challenge that they face is that to create like this NP hard problem of this delivery assignment. So if there is a way to optimize it further, so that's something that everybody would want to look out for and create. Second is about the algorithm vision. So we need an optimized algorithm which gives more coverage, faster delivery, and minimum wasted time for the delivery executive. So essentially, that something which reduces the wasted time of the delivery executive. So that's the vision that we have collected. Next is
Yeah, so the business knowledge that we would require is the domain understanding, the customer behavior modeling, and the restaurant service rate modeling. Based on these we could develop our test ideas around these.
Yep. Next is the legal aspect. So any like data that, for example, customer location related information or anything. So this algorithm should not store it in any form. So that could be a legal concern, and this is something to watch out for. That there is no the algorithm is not putting it somewhere or saving it or like manipulating it in a wrong way. So or exposing it. So that's a legal aspect that we have to check out for. Then next is the team. Yes.
Yeah. So for the team, as a team, we could think on creative ideas, lateral thinking techniques. We could use the 6 thinking hats technique, the random stimulation technique, and Google goggles.
Yeah, and maybe we have some internal collections from team, so we could use that to create some product specific quick test. And as us, we bring in some we need or we bring some experience about the domain, about the skills that are testing skills that we bring to the team, and knowledge and familiarity would be uh, product, algorithm, and competitors. So this is something that we have to get more knowledge and familiar with about the product, about the algorithm, and about our competitors. So that is the teams part, and next is the stakeholders. Sorry, external.
External, yeah. So we could use resources, external resources like public collections, like 400 software error book, the testing cheat sheet, and the little black book of test design, from which we have taken this mind map and we have put in our ideas here. So based on these resources, we can think on those lines.
Yeah, and one good reference would be, for example, something that we would like to refer is that how Google Maps does and processes all this location related data. So this is a good reference for us. Because of timing issue, maybe it doesn't fit for us, but it will give us some good insights on how it works. So that's the references, and yeah. Search for more and relevant data by using some power searching tips, because we'll have to do a lot of research. So that is something that will help and stimulate our test ideas. So, yeah. And last part is the stakeholders. Yeah.
Yes, for quality characteristics that we would work on our usability. So how easy is it to consume for the application, the algorithm, and create test applications using the algorithms. So we could do that. And for performance, we could test the speed with which the algorithm is running, the complexity analysis, that is the time space factors that we could consider, and the testability.
Yeah. And next is the product fears in the stakeholders. So first fear is the loss of image. So loss of image, first is the false claim, so which we were talking about here, where we were saying that if it commits less or commits more in both the time, there is this fear that the customer would essentially have a bad image of us and leave us, breaking promises or giving too much time or taking too much time. Next is taking wrong decisions. So maybe for some place like NOA assignment would have been better, but the assignment is done as batching, so that could be a wrong decision and could again lead us to some wrong things. So such kind of things should not happen. And third is the damage. So the damage that can happen if this algorithm doesn't work fine is the lost customer. We even lose a restaurant because maybe we are not showing them or not servicing appropriately to them, or maybe a lost delivery partner and delivery executive, so they leave us. So these are all in all the test ideas. And before we take questions, I would like to just showcase the references what we have taken. So we were going through this Swiggy blog on this delivery challenge, from where we got to know about all these data points and why Google Maps don't work and all these things and factors which I was explaining in the earlier part. And this is a two-part blog that we have referred. We also referred this food delivery algorithm video by Gaurav Sen. So he explains about how this works and all in the designing part, and how this location or historical database works helps and all. And then this little black book of test design which we used for noting down our ideas and all. So, yeah. that's pretty much
Yeah, it's very comprehensive, Rahul. So that I would say. And when I was doing this online research, I found something like a different business models. Let's say the business model. What they are saying is the order only model. So where the in this model, basically what they were saying is the customer directly goes to the app and places into the specific restaurant, and the restaurant will have their own players as executives to provide the service. I mean, that is nowadays, I don't think it is happening. But the next one is they were saying order and delivery model. So even in this case, so the same process, but only thing is the restaurants won't maintain the deliveries. There is a different company like altogether they provide the services. And third one, what I heard is like cloud restaurant. So that is, I think that is where all these Uber Eats and everything is coming. So there is no restaurant, it doesn't maintain anything, and so even in the and the point what I read is that there is no in-person dining restaurants available. They are like kind of the restaurant image is there. I mean the presence, but not like an in-person. So it's like kind of they won't take any like in-person dining services. So based on those models, these ideas won't change, correct? So pretty much like delivery of the food would be the same, right?
I have one question, Rahul. How can we test algorithms?
How can we test algorithms?
Yes. So let's say for developer has implemented NP hard problem. So as a tester, if you want to test, then how actually we can test? We are testing UI. That is not at all. We are testing the algorithms.
No, we are not testing the UI. Definitely, when we have to test the algorithm, we don't even have to test the code. It's actually the complexity of the algorithm, that how it's designed, and there is this. There are different analysis for it. For example, first would be the time complexity and space complexity, which is very common, which we see.
Yeah, that is for the how they have implemented. Based on the complexity, they are going to implement the algorithms. The now thing is how we can test. Do we actually need to understand the coding principles, or directly we can jump into any algorithm and we can test?
We don't need to know the coding principles, because coding is not there for algorithms. Like essentially there is no code that would be there for algorithms. But essentially what we can do is we can pass. I am getting an echo. Yeah. So what I'm saying is that essentially we pass some data sets in an algorithm and check how it gives an output, and maybe compare it with our old algorithm or existing algorithm or product which we are using as an oracle, and find a way to optimize it and all. So it also depends on the actual changes that they have made, but these are some things which can help us to identify areas where we want to test it. For example, if we get some rumor, then maybe there we want to test it out and see that what is the issue that people are reporting and all.
So basically, the algorithm, how is it impacting all these areas? So when it is impacting all these areas, so we just want to test it, how we can improve it or optimize it.
So at one place you have written, I think that we need some tools for testing algorithms. So whenever we do testing, we are actually testing algorithm, right? If I give you a text box where you add some numbers and are they getting sorted or not, so behind it there is algorithm, right? And based on your input set, like whatever factors we have decided, and we say that this algorithm works on the basis of this factors. So as you said just now, that we can just vary those input factors and see how the output is getting affected. So if it is getting affected, that means that those factors are being taken into the algorithm. So indirectly, every way a logic or algorithm is getting tested whenever you are using a software, right? So that is, algorithm is only getting tested. Software program is nothing but as algorithm.
It's the implementation of the algorithm which is getting tested.
So So you mean to say we directly we are not at all testing any algorithms. We are just checking UI. That's
No,
it, right?
I'm saying the reverse of it. I said the reverse of it. That whenever you are using it, you are testing because some algorithm is implemented, right? Somebody told.
Yeah, but whenever we are using from the UI. We don't know what is happening backend side. For example, for one operation, let's say we are logging to Swiggy as a from Google. From Facebook. So there are multiple algorithms behind it. There are multiple integrations behind the sign up process or login process. But we are performing from the UI. So how we can get to know which algorithms we have tested, or
Yeah.
what is the please.
Yeah. So just Rahul, to answer that. So I think what you are asking is, see, you are not. Here is a trust issue, right? For example, if I tell you that there are 9 types of sorting algorithms, right? So if you are using it as an end user in a UI, you enter whatever. It will give you all the 9 sorting algorithm will give you the right output, right? You cannot just say that, okay, it is bubble sort, heap sort, mud sort, radix sort. So if you want to test that, you have to see the code and validate it. Like, so if the developer is saying that they have implemented that algorithm, I think in my perspective, you can just vary the inputs and validate whether the output is on those factors or not. So if we are saying that it depends on the delivery, like say weather condition. So if it is raining and without raining, it's giving the same output, that means that factor is not considered actually. Yeah, sorry Rahul, go ahead please.
Yep, that's correct. Another point I want to add to what Gaurav said, that when we test the application, we essentially test the algorithms. It could be true, it might not be true, because when the application is developed, they actually implement some algorithm. Now maybe the algorithm is correct, but put it in the wrong context. So, for example, there is an algorithm for sorting, which is fine, but you put it in a context where some different kind of sorting is needed. So there is no issue with the algorithm, or the algorithm is correct, but the context is wrong. I mean, it is just misfit. So then this algorithm is, it's fallible.
Yeah, so I have one scenario here. So for example, let's say I'm going to buy pizza from Swiggy app, and it is going to suggest me you would like garlic bread or you would like some cold drinks. So how they will get to know if I don't know the algorithms? Basically, I as a tester, I am seeing in the UI it is suggesting. As per the business scenario, it is suggesting. So everything is correct. But if I don't know algorithm, then how can I make sure that along with the pizza, it has suggested cold drinks, which is correct or not? Or if cold drink is not available, then which product it should suggest?
Okay, can I add something?
Yeah.
So what Nishant seems to ask is right. Without knowing the algorithm, relying only on the UI might not be 100% true, or might not be the way to go in all the cases. Like he very well highlighted the login example of different logins. Through the UI, you are logged in. But how you are logged in, what mechanism was used internally, that you might not be aware of. And what Gaurav said will be true if that is the only algorithm, and it it is being used and that implementation is reflected in the UI. Now, what Rahul said in terms of like algorithm is right, but it is not implemented there. Then algorithm is not tested. Something else has been tested whose output you see in the UI. So it is always good, I would say, to understand what is the algorithm independently, see where it is implemented, and then test both. Test algorithm like at a unit level, test just the algorithm, and test the implementation of the algorithm. Both of which are different. Testing the algorithm and testing the implementation of the algorithm are different. Do we all agree to that? Algorithm and implementation of algorithm are different.
Yes, definitely.
Yeah.
Right? So as long as we understand that testing the algorithm and testing the implementation of the algorithm are two different things and need to be done. To have confidence on both of these, I think we are in a good place, good shape. The moment we say testing UI is enough because we will trust the algorithm versus I will test the algorithm, I don't care what happens in the UI, both of these are, I would say, extremes, which which as much as it is avoided, it's good for the product.
So Ajay, adding to what Gaurav said, and I have a confusion here.
For the first time, you
See,
are
the
adding
initial-
something.
Okay, so the example Gaurav given is there are 9 different kind of searching algorithm. My sorting algorithm. My challenge is that I need a sorting. Okay, so as a tester, when I say validate the algorithm, what I can do is I have a set of data and I want that to be sorted. And end of the day, that sorted result is I'm getting. So does it really affect which sorting was used there until unless I'm really interested in the complexity side of it?
What if I don't use an algorithm at all, but I also give you the results? Then you will not be able to tell whether I use the algorithm or not, correct?
Obviously, I'll not be able to.
That's
tell
the
that.
reason you need to know what is happening so that you can test in a way that proves that that algorithm was used.
Okay. Yeah.
What if I am giving you results in a random way, which is matching the algorithm's expected value? You try 20 times. 20 times I am giving you the exact match. 21st time I will fail because I am not using that algorithm.
Yes. Okay. Yeah. Get.
So how you can test in this case? If we take the same example, like you tell that okay, we have not seen it, but 21 time it can fail. So you mean to say that you are analyzing the code to confirm, right?
Correct.
How is it?
It's like finding out what is being implemented and then thinking on the lines of how can I make it fail, and confirming that okay, if I use this it failed. Oh yes, it failed. So it is definitely that particular algorithm is being used. It is not just the expected behavior of that. I mean, in terms of what you expect the algorithm to do, not just testing that value, but you also expect the algorithm to not do some things, testing that also. Thereby, you are confirming that oh yes, this definitely is not happening. Switching on light, switching on and then switching off, testing both, rather than saying okay, I press the switch down, it light glows. Are you sure that this is in touch with that bulb or something else is controlling? So that is where I think Nishant was trying to say that UI as the sole source of testing might not be a great idea. In conjunction with the algorithm being used and then the UI, then it makes sense. Having both sides of algorithm and then the implementation of the algorithm. Okay, I have a few questions. Rahul, Apoorva, you said if DB goes down, calculation might be affected. Have you thought of that is historical data, correct? Have you thought of backup? It is not live data. It is a backup.
Yes.
That data need not be live. It is right.
Yes.
Yes.
Okay, that is one. Second, time duration between orders. I think that was slightly touched upon when Devi Prasad talked. Third, if you remember, even before I order, I know that from X restaurant, it will take 20 minutes. There is no delivery executive assignment yet.
Mhm.
What do you call this part as? Restaurant serviceability time?
Just to understand it, you say that you know that it would be delivered.
No, the app shows X restaurant delivers in 23 minutes.
Okay.
Y restaurant shows 50 minutes.
Okay.
How is this related to the final delivery time calculation? Are these two calculations same, similar, different?
Similar.
Okay.
The thing that we promise here at the start, when you load the app, this is like all the delivery positionings and delivery executives and everything is looked up to come up with that value, so that value is given to you. So in actuality, I mean, if they promise you 20 minutes, in ideal situation, what they would want to do it is to deliver it in 18 minutes and maybe to extend it to 22 or 23 minutes. But going far, then they will like start putting that, sorry, we are running a little late or something.
Okay.
To add here, here also they are using different algorithms or AI. For example, let's say I am ordering as of now and it is raining outside. So they will capture the data whenever it was a rain and heavy traffic in my area. So by that time, how much time it took in past deliveries. So based on that, it will suggest me my current order. If there are no traffic, no rain, no office time, so by that time it will going to take less time. So based on that, for example, by that time I'm going to order, so it will give me less time. So there are also multiple algorithms behind it.
Yep. So that's a variable, the traffic or the weather and maybe other factors which you decide.
So, right. One thing that I felt missing was testing that algorithm in isolation. Forget food delivery app, forget any app.
Mm-hmm.
If XYZ algorithm is used, when are you testing that algorithm in isolation?
Okay.
If you are not testing, then you are using it. You are not testing it. You are testing the implementation of it, or you are testing the, what can I say? You are testing the usage of it, right? You are not testing the algorithm.
Correct. Correct. So test in isolation. Yeah. I think that would
be the mind map. Test the algorithm.
And for that point, Ajay, the backup of DB, so both can go down, right? Whether it is active or it is a backup. So their case was DB goes down, whether it's live or backup, they were using it, right? So if it goes down, both can go down or both can have a backup.
Right. And all of you who are here, what do you think of the effort that has gone into this exercise from Rahul and Apoorva?
I would say some good hours. I'll say day actually. Some good days.
Okay. I would have wished multiple people to have participated, but then once nothing to take away from Rahul and Apoorva's effort. Even if there was one more or two more entries, I think this would be one of the top entries. So I have something to give away for them, and that is, let me just paste the URL, and I think that should help. Just launching it once again. So they are getting a free ticket to one of the conferences, and the conference name is, let me paste that URL here. So it is just one ticket. I think they will have to share. Yeah, so they're getting this ticket where they could also attend the workshop. And yeah, Rahul, you might want to click on it and then click on the message in the Google Meet and then show the ticket.
Yes. QA Summit.
Okay, it says buy one get two, so they are sorted.
So yeah, what is the ticket? Can you click on book your ticket?
Yeah.
What's the cost? Or maybe you could go to the previous tab and click. Yeah.
It's a $150.
Yes. Yeah. So this is the price for your small effort. In fact, a small price for your big effort.
No.
Right?
Thank you, Ajay.
Yeah.
Well done. And yeah, we'll discuss more about this in future. So very well done. In fact, you are getting better at presenting mind maps. Little more work to be done in the test ideas section. I think with practice you will improve, right? And yes, collect more examples, and hopefully these kind of exercises help you in sharpening your testing skills. Yeah. Good. Thank you everyone for attending, and if you could just switch on your cameras, we could take a photo and then can say a good start for the upcoming week. Chandravan, I told you participate. Abhi aisa move.
मेरा मुंह ही ऐसा है मैं बना नहीं रहा सॉरी
Nishant Mahati joining.